students, welcome back to my channel Physics in a Nutshell. I hope all of you are safe, staying at home and preparing well for your exams. So in this video, I'll be explaining about electricity topic. Since I have received a lot of requests from the students end stating that the topic is tough and it's a bit confusing, so that is the reason it's my pleasure to take up the topic and help out the students. So I will try to simplify the concepts of electricity in this video. So I request all the students to watch the video till the end so that you can understand the topics very clearly. Now let us study a few important definitions of this chapter. Coming to the first definition of current. Current is defined as rate of flow of charges in unit time. So basically current is nothing but the rate of flow of charges. If you take a metallic wire or a simple electric circuit, so there is a flow of charges. So that is why we say that the current is flowing in the wire or in the circuit. So now let us consider a simple electric circuit by connecting a bulb to a battery and a switch. Let us mark the direction of the flow of the current from the positive to the negative terminal. This is a simple electric circuit constituting of a bulb, battery and a switch. And it is very easy to understand that whenever we put on the switch, the current starts flowing through the circuit and the bulb will start glowing. So why does this happen? Why does the bulb glow? This is because of the flow of the charges in the metallic wire. So this flow of charges is nothing but the electric current or electricity. So I hope it is very clear. The flow of charges or the flow of negatively charged particles, that is the electrons, that will constitute the electric current. Now let us study the SI unit of current. SI unit of current is ampere and it is represented by the letter A, and the symbol for current is I. I is equal to Q by T. So in this formula, I is the electric current, Q is the charge and T is the time. As we have defined the current as the rate of flow of charges, so current is nothing but the flow of charges in unit time. So that is why I is equal to Q by T. And the SI unit of current is ampere, and we have smaller units of current, that is nothing but milliampere and microampere. So these are the smaller units of current. To measure the weak current or very small amount of current when we are basically working in the laboratory, we are using a very small amount of current. So to measure the small amount of current or the weak currents, we are using smaller units of current, that is milliampere and microampere. So just we can take an example of measuring distance. Meter, SI unit of distance is meter, but the smaller units are centimeter, millimeter for measuring very small distances. Similarly, here also for current we have smaller units, that is milliampere and microampere. So 1 milliampere is equal to 10 to the power of minus 3 ampere, and 1 microampere is equal to 10 to the power of minus 6 ampere. This is the relationship between the milliampere and ampere and microampere and ampere. 1 milliampere is equal to 10 to the power of minus 3 ampere and 1 microampere is equal to 10 to the power of minus 6 amperes. Now let us define what is 1 ampere. As we have written the formula, I is equal to Q by T. That is nothing but current is equal to charge by time. So let us write the units. Unit of current is ampere. So let us consider 1 ampere is equal to unit of charge is coulomb. So I will be writing it as 1 C divided by unit of time is seconds. So I am writing it as 1 second. So this is how from this formula easily we can define what is 1 ampere. When 1 coulomb of charges flow through a circuit in 1 second, then the current is said to be 1 ampere. So it is very clear. Without any memorization, easily you can understand and you can remember this particular concepts. Like when 1 coulomb of charges are flowing through the circuit in 1 second, then we say the amount of current flowing is nothing but 1 ampere. So this is how easily we can remember. And the current is measured by using a device called ammeter. So how do we define an ammeter? It is a device used to measure the amount of current flowing in a circuit. So let me show the ammeter. This is a ammeter. As you can see here, it has a positive and negative terminal and it can be easily connected into the circuit to measure the amount of current flowing through the circuit. And we can read. There is a red needle over here and the needle deflects and it will show the amount of current. Basically here it is milliampere. So whatever the reading we are taking, for example it is 100 milliamperes. So we have to convert the milliampere into amperes and then we have to record it. Now let us understand the definition of potential difference. What is potential difference? It is the work done to move the charges from one point to other point in the circuit. Basically when the charges have to move from one point to other point, it needs some work. So for example, if we are moving an object from one point to other point, some work has to be done. So when we do some work only, we are spending some energy and we are able to move the object from one point to other point. So similarly here also, what happens with respect to the charges, when the charges have to move from one point to other point in the circuit or in the metallic wire, some work has to be done. Okay, so that particular work done to move the charges from one point to other point, that is nothing but the potential difference. And the potential difference is represented by the letter V, and the formula is V is equal to W by Q, where V is the potential difference, W is the work done and Q is the charge. Then how do we define the volt? Because SI unit is volt. SI unit of potential difference is volt, represented by small v. So how do we define 1 volt? One volt is defined very easily with help of this formula V is equal to W by Q. From this only we can define 1 volt. So the work done, when the work done is 1 joule on the moving charges 1 coulomb, then the potential difference is said to be 1 volt. So I repeat, when 1 joule of work is done on 1 coulomb of the charges, then the potential difference is said to be 1 volt. So easily you can remember through this formula. And the potential difference is measured using a device called as voltmeter. So how do we define a voltmeter? It is a device used to measure the potential difference across the ends of the conductor. So this is a voltmeter. You can see the positive and negative can be connected over here, and the voltmeter is represented by the symbol V. So you can see the symbol over here, and there is a needle which is deflecting. Now when this voltmeter is connected in the circuit, it will show the amount of the potential difference across the ends of the conductor. Now let us understand the definition of electrical resistance. Let us consider a metallic wire which is connected to a battery and a switch. So once we switch on, there is a current flowing through the wire. So what happens exactly? While the current is flowing, what happens? the particles inside the wire will obstruct the flow of the electrons. So as the electrons are moving, the particles inside the wire will obstruct the flow of the electrons. So that particular obstruction offered by the particles of the wire to the flow of current, that is nothing but electrical resistance. So we can define resistance as the obstruction offered by the particles of the wire or the metallic conductor to the flow of current. Obstruction offered by the particles of the wire to the flow of current. This obstruction is nothing but the resistance. So the particles present in the wire will try to obstruct the flow of the current. So this obstruction is called as electrical resistance or resistance. The resistance is represented by the symbol R, capital R. And the formula for resistance is R is equal to V by I, where R is the electrical resistance, V is the potential difference, and I is the current. And the SI unit of resistance is ohm. SI unit is ohm, represented by the symbol. This is the symbol of ohm. So we have studied the important definitions of current, potential difference and electrical resistance along with the SI units and formulas. So these concepts have to be thoroughly understood and studied, and I will be explaining about the Ohm's law in my next video. So please watch my videos completely to understand the concepts in a detailed manner, and please do like, share, subscribe to my channel, and I'll catch you in my upcoming videos. Thank you.